Let me tell you something about yourselves that you barely ever think about. You interact with fabrics 100% of the time. We're all wearing clothing right now to keep ourselves warm, dry, and comfortable. We sit in our car seats, in our office chairs, or on our sofas on fabrics. And from the towel in the morning to the blanket we pull over ourselves at night, we're using fabrics all day long. And it's not just us today. We have been using fabrics for over 35,000 years, and our bodies have physically adapted to them. That's what makes them so interesting to me. So after 35,000 years of research, you might think all problems are solved, right? Until you see somebody struggle to put on a compression stocking before a long flight. These stockings provide pressure to increase blood flow and decrease blood clotting. However, they're very undersized and difficult to put on, especially for the elderly who are most in use of them. Throughout my doctorate, I've been working on a new fabric paradigm called smart fabrics, which are able to solve the problems of compression stockings and many other current fabric problems. The problem with fabrics right now is that they're passive. That means that they can be designed for a certain use case, but they're not able to adapt to different situations. Smart fabrics can do that. What makes a fabric smart? Instead of using the traditional materials like cotton, I use smart materials that are able to adapt to a change in environment. Their properties change. These changes in environment can be, for example, a change in temperature, a change in electricity, or the presence of a magnet. Now, when I use a smart material in my fabric, the fabric can change its shape when the environment changes. It can shrink, it can roll up, it can fold up. It all depends on how I design it. The fabric that I most closely look at is a temperature-reacting shrinking fabric. So it shrinks up when the temperature increases. This is very useful for the compression garment application because it can be oversized at room temperature and then heat up to body temperature, shrink, and provide the pressures that are needed. My task now is to really look into these fabrics and figure out how much they can shrink and how much pressure they can provide. I look at 3 different levels of focus. My first level of focus is the full fabric. It's a knitted fabric that consists of many knitted loops. And I found that by increasing the number of loops, I can increase the shrinkage magnitude and the pressures. My second level of focus is the knitted loop itself. I've looked at many different geometries and sizes, and I can tell you that larger knitted loops lead to more shrinkage, but there's a decrease in the pressure, so there's a trade-off on this level. And my last level of focus, I really zoom in, and I look at the crystals that make up the smart material that I'm using. There are 2 kinds of crystals. One that tells me that the properties have already changed, and the other that tell me that the properties haven't changed yet. So when I use all this information and put it together, I can accurately design temperature-reacting shrinking garments for using compression stockings. And since you're all experts in this subject because you use fabrics all day long, you can probably help me come up with more applications where these kind of fabrics can be useful. Thank you.